gravitational potential energy that we talked about starting yesterday.
That one. Okay. That went through every notebook and it had to be the last one.
Oh.
All right, so make sure you write the topic and essential question into your notebook first. So write the topic and essential question into your notebook first.
I'm going to write it on the second to last side.
All right, so how do living things use energy? When we talked about systems inside of your body, we talked about the digestive system and how your body takes in food, and then it converts that food into glucose that your cells run on. When we talked about cell respiration, okay? And you use the energy that is taken in by you eating, that chemical energy, and you use it to do all of your life processes, running, walking, talking, sleeping, even breathing. All of those things require energy. Your body is constantly using energy, constantly transforming energy. Okay? And we'll talk about different types of energy that your body has in it. All right, energy is the ability to cause change. Your body is constantly changing, either its position or the position of something inside of your body, meaning when you eat, it travels from your mouth to your poop chute, right? When you run, when you breathe, blood travels around your body. Hormones travel around your body. Those are all changes that are happening. You've got lots of systems inside of your body, right?
Mm-hmm.
Yep.
Oh, wait, hold on. Wait, you use this energy to go to sleep? But
You can use energy while you sleep, yes.
But then don't you get energy while you sleep?
No.
I hate having to wait.
So do you only get energy from eating?
You only get energy from the things that you put into your body.
So why when you when you don't sleep,
It's not that you don't have energy, it's that your body needs you to rest. Meaning you need to stop using so much energy.
Oh, so it's still consumed, but it consumes at like a slow rate.
Because when you are, your energy consumption goes down when you sleep.
Oh.
So your body needs you to slow down. That's why you rest.
Oh,
okay. Energy. In order for you to remain alive, you have to use energy every second of your life. If you run out of energy, you die, right?
Oh,
yeah. My grandma almost died because she her heart beat slow, like really slow.
And your body doesn't get the energy that it needs. All the cells need that energy.
So that's why you
energy makers
because if you just stop eating, that's why.
You're constantly needing energy. You either get the energy from outside, or your body will start actually eating itself to get energy. So it starts off with something easy. The easiest thing for your body to break down is going to be your muscles. And then from there, you've got fats as well. So you've got muscle and fat that it'll eat first.
Good thing you'll eat the fat first.
Oh, that's why people die.
Fat is just more complex.
Oh.
Okay. There are two types of energies, two main types of energies we kind of talked about. We talked about energy in motion. Which one's that? Kinetic. We talked about stored energy. Which one's that?
Potential.
Potential. Okay. Those are two of the main types of energy. Now, from those two, you've got different types of potential and different types of kinetic, right? So you've got potential elastic, right? You've got chemical potential. You've got
Is it medicine?
no, I just hear music.
Yeah, I do too. What?
It just stops. It's like it's kind of suspicious.
It's kind of sus, man. take long enough to cut it like
It still is.
All right, so
but it's not thick enough.
chemical potential, elastic potential, gravitational potential were all types that we talked about yesterday. Okay? Potential energy is either its position, which would be gravitational potential, right? Condition or chemical position or chemical composition. So why does your body eat the things it does? It's to get the sugars out. Things that you eat have either complex sugars or simple sugars, okay? And your body takes those sugars and there's bonds in the chemical of sugar or glucose. And it'll break those bonds to release energy. And that's what's going on in your body. So that's what it's talking about, chemical composition. Position. Position is usually going to be gravitational because the higher you are, the more potential you have, right?
Yes.
For position. When an organism is able to move but is resting or still, it has potential energy. So you have the most potential when you are staying still. A resting organism has more potential energy than kinetic energy. Clearly that's true because you're resting, you're not moving, right? When you're asleep, your body slows down. Less kinetic energy, more potential. An organism that moves or falls from a higher position to a lower position decreases its total potential energy. We'll talk more about that here in a second when we talk about gravitational potential. The lower position you are decreases your potential energy, while as you are basically going down, your kinetic energy increases, right? As you lose potential, you gain kinetic. As you lose kinetic, you gain potential. Basically, they are like that. So, example is a basketball. So, as the basketball goes down, is it gaining potential, losing potential?
Oh, you actually have
As the basketball goes down, is it gaining potential or losing potential?
losing.
Gaining because it's gonna go down and then it's gonna start losing it when it goes back.
So does it have more potential up here
Yes.
or
Yes.
down here?
Up
Up
there.
there.
Up there.
Up here. So as it
Up
goes
and
down, it is
Losing.
losing potential.
Wait, I was
Okay.
thinking of kinetic.
As it goes down, is it gaining kinetic or losing kinetic?
Gaining.
Gaining kinetic because it transforms that potential energy into kinetic energy. Okay? Now if it drops and it bounces, does it bounce as high as I drop it from?
No.
No. Why?
Because it
Because
loses.
has nothing to force it back up as it pushes
The
down.
reason why it doesn't bounce as high as it starts is because there is a loss of energy somewhere. Okay, you can lose energy through heat, sound, stuff like that, right? So if I drop it, clearly it doesn't come back to the same spot. Okay? Did you hear a sound?
Yes.
That is a type of energy. The basketball lost energy from that sound, right? So it had potential energy, gravitational potential. It loses it as it goes down, right? Gains kinetic. That kinetic energy is then also pushing it back up, right? So it gains potential as it goes up and loses what?
Oh, kinetic.
Yeah. So they're just opposite. One is increasing, the other is decreasing when you talk about kinetic and potential energy. Okay? Energy conversion. There's two more diagrams that are basically stating the same thing as what this is, just in more detail.
Good
Like
tell.
this one. So if you took a ball and threw it up high and then caught it, this is what is happening between the potential and kinetic energies. So you have the most kinetic energy as you throw the ball. Okay? You have the most kinetic energy as you throw the ball. But after it gets out of your hand, that kinetic energy is being transformed into what?
Potential.
Potential, because its position is changing. Okay? As it moves, it reaches what is called its highest point. when it's at its highest point, you have the most what?
Potential.
You have the most potential at its highest point. Okay? As it comes back down, it transforms that highest potential, right? The most potential energy into what again?
Kinetic.
Kinetic energy or energy in motion, right? As it is moving, does it have both kinetic and potential?
No. It doesn't.
Look at the graph. Does it have both kinetic and potential?
Yes.
Yes. As it moves, it has both kinetic and potential energy because of its position changing and its motion. So as a ball moves upward, its speed and kinetic energy decrease. So as you throw it up, it slows down, right? As you throw it up, it slows down. It has the highest speed as it leaves your hand, right?
Yes.
And as it goes up, it slows down. So its speed and kinetic energy decrease.
Why not when it comes down?
When it comes down, its speed and kinetic energy increases. Yeah, rises.
Yeah, buddy.
So it says, but the potential energy increases. So as the kinetic and speed are decreasing, the potential's going up. And then as it falls back down after it reaches its highest point, its speed and kinetic energy start to increase again. But what decreases in that case?
Potential.
Yeah, that potential goes back down. So when does a ball have its most potential energy?
At the top.
Yep, at its highest point. Okay, when does the ball have its most kinetic energy?
At the very
On the
end
way
and at the very
down.
beginning.
Not at the very end.
On the in the or
At the very
in middle,
beginning.
In the middle.
Oh, when you have it in your hand.
When it's releasing, right? So when you throw a ball upwards, it is moving the fastest. If it's moving the fastest, that means it has the most kinetic energy at that point. So as I release the ball, it has the most after my fingers let go, right? As the ball comes back down, it gains kinetic energy, but it won't have as much as when it is released from your hand, right?
That's when the ball.
Because that's when the ball's traveling its fastest. If ever you watch baseball, a lot of times they'll talk about exit velocity, okay? And that what they're talking about is when that 90-mile-an-hour ball hits the bat and the energy or the speed it's about to launch, right? So the higher the speed, more likely the longer it goes, right?
Wait, so like, what about when you hit the ball and then when those two make contact? Is that potential energy?
There's a transfer of energy. Okay.
Yeah. So
You can actually hit a faster ball. So if you hit a fastball, it will leave the park.
Slow.
It'll go faster out of the park.
Yes.
Yes.
Yeah.
Because it has its own energy
If
and in the
you
back
hit
end.
a curveball, it's harder to make it go longer.
Well, yeah, because it's like crazy.
Exactly.
Well, even if it wasn't curving and you hit it just like you hit the fastball will go further.
Because the impact of the bat.
Well, yeah, but
With the
Because of
faster ball.
transfer of energy.
Yeah.
Okay? The transfer of energy. When the bat hits the ball, the transfer of the energy that ball has, that kinetic energy, hits the bat, but it also transforms it back out when it hits the bat.
Oh,
Okay? So
I
that increases the exit velocity depending on how fast the ball is being thrown.
swung once and it put a dent in the end of my bat and then it went nowhere. It like rolled to the pitcher because I hit it and it put a dent and it just stopped right there.
Because some of the energy
And that was very end.
the energy wasn't transformed into exit velocity, it was just transformed into the dip in that case.
That was a gnarly curveball.
Okay?
Oh,
Alright, so as long as you know that it has the most kinetic
T-pose.
as it's being released, it has the most potential at its highest point, you know that potential energy increases depending on how high you get because of gravitational potential energy. Okay? You know when it has potential and when it doesn't. That's what we're trying to figure out.
The guy's debuffing.
So here are some questions. We'll answer these in a little while after I give you some time to answer them. When does it have potential? When does it have kinetic? And when does it have both? So fill out the little lines next to it. Potential, kinetic, or both. Rock rolling down a hill.
Kinetic.
Yeah.
It is not just kinetic. Remember,
Oh.
if there is motion involved, it is losing potential as it's rolling down the hill, right? So does it have potential energy?
Yes.
Yes, so that's transforming as it rolls down the hill. So it still has potential energy, but it's losing potential as it rolls down. So it is
Both.
a rock at the top of the hill.
Potential.
Potential.
Potential, it's not moving at all, so there's no kinetic energy. You sitting in a chair.
Potential.
Potential.
Yes, especially if you're in a classroom that you're actually learning stuff, you've got a lot of potential.
Oh.
Standing up.
Both.
The process of standing up would be both, right?
Yeah.
Because there's motion involved in you standing up. If you're thinking maybe standing still, like you're standing up but you're standing still, but the process of standing up would be both. A penny sinking in a cup of water.
Both.
Yes, if there's kinetic involved, it also has potential, right? Unless there's no gravitational potential, you know, and this does. A styrofoam ball floating in a cup of water.
Potential.
See, I'm gonna say just because there's no potential for it to fall down, right? Because it'll always float.
Unless you put like something heavy on it.
Yeah. So potential. We'll say potential. Throwing a ball in the air.
Both.
Both. Okay. If there's any type of motion, then that means that there was potential energy, and that potential energy is being transformed into kinetic energy. What are some examples of energy found in organisms? All right, so we talked about all the systems that are in your body, and you have 5 senses that make up your sensory organs, right?
Mm-hmm.
Whenever you sense something from the outside world, there is a transformation of energy. Like right now, you are transforming my sound energy. I'm creating sounds with my voice. You're taking that sound energy in through your
Ears.
ears. Your ears take that sound and turn it into an electrical signal that goes to your brain. If you didn't know that your body runs on electricity as well as the stuff that you eat, right? The chemical energy, now you know. Yes?
But can we also be killed by electricity?
You can, because your body can only take so much electrical impulses. If there's too much electricity,
Is that also why they use electrical things to bring you back after you die?
to jumpstart your heart, yes.
Oh yeah. If you're right at it.
So think of it this way: if I had a really thin wire, thin copper wire, and I put a bunch of electricity on it, that wire will
Explode?
pop. Yeah, it won't explode, but it'll pop. It'll snap because it's too much electricity for that wire to handle. That's why the electrical lines that you see coming from like a power plant or whatnot are very thick. Okay, so the same thing will happen to your internals, right? If you put too much electricity through it. Okay.
Okay. Think of the 3
Let's see
C's.
here. Some common forms of energy. We said we've got chemical energy. The things that you eat are chemical energy. Your body transforms that chemical energy into something that you can use. What do all your cells run on?
Electricity?
Energy.
They run on a type of energy. What is the type of energy that we talked about that your cells run on? Cell respiration.
That's what my next guess was going to be.
That was trying to give you a hint.
Photosynthesis.
Cell respiration.
Glucose.
Glucose is broken down into something your cells can actually run on. Because your cells don't run on glucose, they run on something called
Sugar.
adenosine triphosphate.
What
the? Adenosine triphosphate.
All right, so
I don't know.
chemical energy, we talked about that. Electrical energy, we talked about that just now with electrical impulses. Your brain sends electrical impulses, causes things to happen, right? In your body.
Things happen.
Sound energy, we talked about how it transforms sound energy. I transform an electrical signal from my brain to my vocal cords into words by vibrating my vocal cords so you can hear it. Sound energy. Thermal energy, you all stay at a nice 98.6 degrees. That's where your body likes to be, right?
Oh, you have a fever.
Thermal energy.
No, mine's
Mine's gonna get higher than that all the time.
There's also what's called mechanical energy. Like moving your body would be mechanical energy. Okay? Mechanical energy. Chemical energy, we talked about chemical energy. Does your body store chemical energy anywhere?
Yes.
How does your body store chemical energy?
Oh, they said doesn't.
You are correct. It does store chemical energy. How does it store chemical energy?
Stomach acid? I don't know.
your stomach by eating, right?
Okay, you eat stuff,
And
and if it's too much food, what does your body do with the extra energy?
It stores it.
It stores it. How does your body store extra energy?
Oh, it puts it somewhere.
Somewhere it puts it.
If you eat too much, what happens to your body?
You get fat.
And that's how your body stores extra energy.
Exactly, but then whenever you,
Okay?
but whenever
It
you,
stores chemical energy, right? You're constantly breaking down chemical energy too, right? Oh, you just go like this because
That's cool.
Why am I hitting myself in the head?
electrical energy. Electrical energy. We talked about electrical energy. Electrical energy is a position energy. Basically, what's happening for electrical energy is it's transferring electrons down a chain. Okay? Energy, electrical energy flows in one direction. Electrical energy flows in one direction. Electrical energy flows in one direction. And it's all about changing the position of a charged particle. A charged particle is just an electron. Okay? So it moves down the line. It's like a river. It flows one direction. Vibration energy. Clearly vibration is a movement, so it is a kinetic energy, right? Because vibration doesn't happen without movement. And it generates sound energy. So sound energy is just a vibration. Thermal energy is a heat. Okay? Thermal energy is a heat. And heat is produced when you excite particles. When I say excite particles, it's talking about motion. So the hotter something is, there's more motion involved. Okay? So the hotter something is, there's more motion involved. Think of it this way. Think of the three states of matter. Okay? There's a solid, a
Liquid.
and a. Okay, so there's three states of matter. Which ones are more excited? Is it going to be the solid? Is there more motion in those?
No.
No. Is it going to be a liquid?
Yeah,
There's
no.
going to be more motion involved there, but the most motion is going to be with a
Air.
gas. Okay?
Oh.
So the hotter it is, the more likely it turns from a solid to a liquid to a gas, right? Because those molecules are getting excited and moving around more. Okay? Yeah.
At the end of class, I found one of the paper things. Mine got ripped in half.
Wait, so can metal do that?
Or paper things.
Yes, metal can also, if you heat metal up,
The class
it'll
one.
excite the particles and make it to where that solid becomes a liquid.
You got yours yesterday.
But can it like turn into a gas?
Yeah.
I don't think it's
Like in
ever
fourth
been
period.
hot enough to turn into a gas.
There has to be like over 1,000.
I don't know for sure. I don't
Because
know
I
for
know
sure.
they.
This fucking scares me.
I've missed
I don't think anybody on Earth has done that, so.
It's kind of
got
quiet
hot
in
as
there.
that.
You can evaporate it.
All right, next one, it says
Don't beat me there,
energy
yeah,
transformation. We talked about energy transformation when we talked about throwing balls in the air. Transforming kinetic energy into potential energy and then back, right? Your body transforms energy types all the time. Whenever you transform an energy type, there's usually energy lost. When I dropped the basketball, some of the energy turned into what that you heard?
Sound.
Sound energy, right? When you eat something, some of the energy is lost in heat. Some of the energy is lost in sound, right? So when you transform one to another, not all the forms are directly usable, right? So if I transform the food that you eat and break it down in your digestive system, right? It's not something that your cells can use yet, so it transforms it into something it can use, okay? Energy transformations are not completely efficient, meaning some energy is lost in transformations. When you burn wood, is energy given off?
Yes.
Yes, you've got light energy, you've got heat energy, you've got sound energy, lots of different energies. So each of those is a loss of energy if you're just trying to get as much energy out of the wood that you're burning.
Also, if you put gas on it, you also kind of
Yeah, if you put gas on it, chemical energy. Technically, the wood itself is chemical energy when you are burning. Okay? Energy transformation continually occurs. Your body is constantly transforming energies. Okay? Because you have to use it for your cell processes, to communicate, to form new molecules. We also talked about sensory stuff and how you transform different senses into different information that is sent to your brain through an electrical signal. Okay? So what you see is light energy entering your eyes. Your eyes transform that light energy into an electrical signal to your brain. Okay?
It's also upside down.
Transform the sound energy that you hear into an electrical signal to your brain. Okay? That's the senses. It's all about transforming it into an electrical signal. All right. Hopefully you know about potential energy and kinetic energy. Hopefully you know that there are 3 types of potential energy we talked about. Definitely one of them, gravitational. Yesterday you also learned about elastic and chemical. We talked about chemical again today. Okay. Hopefully you know different types: sound energy, electrical energy, chemical energy,